Welcome to Simultaneous Equations Level 2. Pause the video now, try the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving 2r minus 3t is equal to 25 and 3r plus t is equal to minus 1. Now to solve this, we'd like to eliminate one of the variables, and this means we need to either get rid of the r's or get rid of the t's. Now to do this, we need to have either the same number in front of the r's in the two equations or the same number in front of the t's, and at the moment none of them match. Looking at the second equation, if we multiply the second equation by 3, we can make both t's have a 3 in front of them. So that's what we're going to do. So multiplying that second equation by 3 gives 3r times 3, which is 9r, plus 3 times t, which is 3t, is equal to minus 1 times 3, which is minus 3. And the equation at the top, we can just stay the same. So 2r minus 3t is equal to 25. Now that we've made the number in front of the t's the same, we can see that they have opposite signs. And this means that to eliminate them, we need to add them together, because minus 3t plus 3t gives us 0. If we add together both equations, starting with the r's, we have 2r plus 9r is 11r. The minus 3t and the plus 3t become 0, and 25 plus minus 3 becomes 22. And this is because a plus and a minus are equivalent to having a minus there, so 25 minus 3 is 22. To now solve for r, we can remove the times 11 from the left by dividing by 11 and doing exactly the same on the right. And on the left, the times 11 and the divide by 11 cancel out to leave us with r, and on the right, 22 divided by 11 is 2. So r is equal to 2 is the first part of our solution. To find the value of t, we now need to substitute this value of r into one of the two equations. And the second equation looks easier to work with because it has a plus in it, so I'm going to choose that one. So starting with 3r plus t is equal to minus 1, I'm going to substitute in r for 2, so we have 3 times 2 plus t is equal to minus 1, and since 3 times 2 is 6, we have 6 plus t is equal to minus 1. To find the value of t, we now need to remove the positive 6 from the left, and we can do this by using its inverse, which is minus 6, and do exactly the same on the right. And on the left, the plus 6 and the minus 6 cancel out to leave us with t, and on the right, minus 1 minus 6 is minus 7. So t is equal to minus 7. And this means that our final answer to problem 1 is r is equal to 2, t is equal to minus 7. In problem 2, we're solving 4x plus 3y equals 32 and x minus 2y equals minus 3. Now again, we'd like to eliminate either the x's or the y's, so we need the same number in both equations, and we don't start with the same number of either. Having said that, we can multiply the bottom equation by 4, and we can see that if we do that, we're going to get a 4x in this equation, which matches the 4x in the equation above. But we need to make sure we multiply everything in this equation by 4. So starting with the x times 4 is 4x, minus 2y times 4 gives us minus 8y, and minus 3 times 4 gives us minus 12. And we can keep the top equation exactly as it started. Now the 4x in both equations is positive, which means to eliminate these, we need to subtract, because 4x minus 4x is 0. So we know that the x's are going to become 0. We now have to do 3y minus 8y. And we need to be really careful here because we have 3y minus 8y, and these two minuses are equivalent to a plus. So we're actually doing 3y plus 8y, and this gives us 11y. And on the other side, we have 32 minus 12. And again, we have to make sure that we understand that these two minuses are equivalent to a plus. And 32 plus 12 gives us 44. Now to find the value of y, we need to remove the times 11 from in front of the y. And we can do this by dividing by 11 on the left and doing the same on the right. And on the left, the times 11 and the divide by 11 cancel out to leave us with y. And on the right, 44 divided by 11 is 4. So y equals 4 is the first part of our solution. To find the value of x, we now need to take this value of y and substitute it into one of the two original equations. Now the one at the top has got a plus in it, and these tend to be a bit easier to use. So I'm going to use the equation 4x plus 3y is equal to 32. Now if we substitute y for 4, this equation becomes 4x plus 3 times 4 is equal to 32. And because 3 times 4 is 12, we've got 4x plus 12 is equal to 32. And we can start solving this by removing the plus 12 from the left. And we do this by subtracting 12 from the left and also from the right. And on the left, the plus 12 and the minus 12 cancel out to leave us with 4x. And on the right, 32 minus 12 gives us 20. We can now remove the times 4 in front of the x by dividing by 4 and doing the same on the right. And on the left, the times 4 and the divide by 4 cancel out to just leave us with x. And on the right, 20 divided by 4 is 5. So x is equal to 5. And this means our final answer to problem 2 is x equals 5, y equals 4. In problem 3, we're solving j plus 2k equals 66 and 3j minus k equals 2. Now to eliminate again, we'd like to have the same number of j's or the same number of k's in both equations. And we actually have an option here. If we times the top equation by 3, we'll make both equations have 3j's in them and we can eliminate the j's. Or if we times the bottom equation by 2, we're going to have a 2k in the first equation and a minus 2k in the second, and we can eliminate these by adding. So the choice is ours. I normally find that adding tends to be a little bit easier, so I'm going to go with the second option, which is multiplying this bottom equation by 2. And if we do that, we have 3j times 2 is 6j, minus k times 2 is minus 2k, and 2 times 2 is 4. I'm just going to write the same first equation above. And now, looking at the 2k's, one is positive and one is negative. So to eliminate these, we can add, because 2k added to minus 2k gives us 0. So we need to add everything in these equations. So j plus 6j gives us 7j. We know that the 2k plus minus 2k becomes 0, and on the right, 66 plus 4 gives us 70. So to now solve this equation, we can remove the times 7 from in front of the j by dividing by 7, and doing the same on the right. And on the left, the times 7 and the divide by 7 cancel out to give us j, and on the right, 70 divided by 7 is 10. So j is equal to 10 is the first part of our solution. We now need to take this value and substitute it back into one of the original equations, and the first equation looks the simplest to use. So starting with j plus 2k is equal to 66. We can replace the j with 10, so this becomes 10 plus 2k is equal to 66. And we can start solving by removing the 10 from the left-hand side. And this is a positive 10, so to remove it, we're going to subtract 10 from the left, and also subtract 10 from the right. And on the left, the plus 10 and the minus 10 cancel out to leave us with 2k, and on the right, 66 minus 10 is 56. Finally, we can now remove the times 2 from in front of the k by using its inverse, which is divide by 2, and doing the same on the right. And the times 2 and the divide by 2 on the left cancel out to leave us with k, and on the right, 56 divided by 2 gives us 28. So k is equal to 28. And this means that our final solution for problem 3 is j is equal to 10, k is equal to 28.